Okay, so we are to Unit 6, Lesson 2. And this lesson has to deal with bisectors in triangles. And in triangles, there's these specific points that happen where certain segments made up in a triangle intersect at a certain point. So the first point we're going to talk about is called a point of concurrency. The first point of concurrency we're going to talk about is something called the circumcenter. Okay? And I'm going to read it, the definition, and then I'm going to explain it. So the circumcenter of a triangle is equidistant, meaning it's the same distance from the vertices of the triangle. So the circumcenter of a triangle is made up of a triangle's perpendicular bisectors. So I'm going to make some markings to show this. Okay? So perpendicular bisectors. So the first perpendicular bisector of our triangle that we would look at, let's just say this one, PD. It's perpendicular, and it splits this side in half. Another perpendicular bisector, PE. It is perpendicular to this side, splits this side in half. And then PF, and it's hard to see PF, but I'll say those are no, don't need those marks. Right angle splits it in half. So if we take the perpendicular bisectors of a triangle, they meet at this point P, which is what we call the circumcenter. Okay, so what I'm going to do in the first example is I'm going to talk about how we find the circumcenter of a triangle from a coordinate grid. So, first I'm going to graph the triangle. The point 0, 3, actually use a pen there, 0, 3, 0, negative 1, and 6, negative 1. So that's going to be the point A, B, and C of the triangle. And if we notice, this looks like a right triangle. Now the way we find the circumcenter is we find perpendicular bisectors. So what this means is we need to find two things. We need to find midpoints, okay? And we need to find slopes. So we're going to find the midpoint of every side. AB, BC, and AC. And maybe what I'll do is I'll use a different color to find the slope. So let's just focus on the midpoints. The midpoint of AB is actually not that bad because it's a vertical line. We can count. AB is 1, 2, 3, 4 units long. So the midpoint is the point 0, 1. So we already found the midpoint. The midpoint of BC, it's horizontal. It is 1, 2, 3, 4, 5, 6 units long. So the midpoint is the point 3, negative 1. So no real math needed there, just counting. Now AC, let's use the midpoint formula, okay? So AC, we're finding the average of the x values, average of the y values. So for AC, 0 plus 6 divided by 2, average of the x values, and then the average of the y values, 3 plus negative 1 divided by 2. So that's going to be 6 divided by 2, which is 3, and then 2 divided by 2, which is 1. So the point 3, 1, which makes some sense, all right? And as far as the slopes go, we are finding the perpendicular slope. Okay? So, two of the sides, the slope, perpendicular slope is going to be easy. So to draw a perpendicular to AB, I just have to draw a horizontal line that goes through my point. Because horizontal lines are perpendicular to vertical lines. So that's the same thing for BC. A vertical line is perpendicular to a horizontal line. And the idea is that all three of these lines, all three of these perpendicular bisectors occur, they all intersect at the same point. So I really don't need to find a perpendicular to AC, because I know if I draw that line, it's going to go through AC at this point. So the circumcenter of this point is the point 3, 1. It's where all the perpendicular bisectors intersect. So this is finding the bisectors, the midpoints, and then the perpendiculars, it's finding the perpendicular slope. And if you want me to go into this a little bit deeper, AC has a slope, goes down 4, right 6, so it has a slope of negative 2/3. Perpendicular slope would be positive 3/2. So I would count, I'll do this in yellow just to show, I'd go up 1, 2, 3, right 2. And that would be my perpendicular bisector. Down 1, 2, 3, 2. So this would be my last perpendicular bisector, which would still go through that point. So, oops, if we look back, and I'll flip back, but the circumcenter is equal distance from, I keep screwing up, circumcenter is equal distance from the vertices, all right, from each vertex. Moving ahead, and I'll fix this a little bit, is some guided practice. And this gives you a chance to find the circumcenter of these two different triangles. So this would be a good chance for you to pause the video, find the perpendicular bisectors of each side, find out where they intersect. Okay, so for the guided practice, I tried to keep it simple. I gave you right triangles, so the midpoints and the perpendiculars should be easy to find. So graphing, for number 1, I got -4, +2 as my circumcenter. And then for number 2, I got 0, -1. So it's just us understanding perpendicular bisector. It's the halfway point, and it is perpendicular, meets it at a right angle. So that's circumcenter. Now in-center, as you can see, I'm not going to have you do any graphing with in-center. I'm just asking you to use some properties to find the in-center. So the in-center of a triangle is the same distance from the sides, okay? So when we look back, now the in-center is equidistant, same distance from each side, okay? So this is formed by the angle bisectors. So angle bisectors split angles in half. So that's what the in-center is formed by. It's formed by the angle bisectors. So when we look at this, same distance from each side, okay? Same distance from each side. So when we look at this, we got to be careful with our examples, but that's an important feature, okay? So for this, ND, NE, if this is the in-center, and I'll highlight with this one, ND and NE, we said in-center is equidistant from all sides, so that means ND is congruent to NE, and that is congruent, all three are congruent to each other, it's congruent to NF. So the equation I can set up, I can set the two expressions equal to each other and solve. So I'd subtract 2x from both sides. 3x minus 1 equals 11. 3x equals 12. X is 4. Okay. Now, I didn't ask for 4. I asked for what's the length of NF. So I've got to take 4 and I've got to substitute it into an expression. But which expression? Well, since all of these segments are the same measure, it doesn't matter which one. So NF, no matter what I substitute in, which expression I substitute 4 into, I'm going to get the same answer. 19. Okay, 19. NF is 19 units long. Okay. when we look at this for part B, can NG be equal to 18? Now to explain this, we've got to understand NF is the distance from the in-center to the side, okay? Meaning any other segment starting at the in-center and hitting the side has to be longer, okay? So, can NG be equal to 18? And the reason it can't be 18 is because NF is the shortest distance. The shortest distance from N to that side AC. So this is the shortest distance from a point to a line or a line segment. So any other segment attaching to this side has to be shorter. So it's not possible for NG to be 18. NG would have to be somewhat longer, some form longer. It can't be the same and it can't be less. So 19 is the shortest distance from N to that side. So guided practice, another one. Determine which is which, what equation to set up. Pause the video, check your answers with me when you're ready. Okay, so QP I think is pretty straightforward to solve for. QP is congruent to QN is congruent to QM. So these are all the same distance from the sides. So I can take those two expressions, set them equal to each other, solve, and I substitute it into QM. But if you substitute it into QN, it really will be the same exact length because they're all the same length. So the equations, as long as you're paying attention to what I'm giving you, they should be fairly simple to solve. So I think you're ready for the practice and the checkpoint now. Make sure you're finishing those checkpoints to the best of your ability. Mainly what I'm looking for is that you know enough to pass the checkpoint. If you're not getting perfect scores on every checkpoint, it's okay. It's doing your best to pass them, to understand enough to move on to the next topic.